Hello everybody and welcome to the fourth Under the Water live webinar. It's my pleasure to introduce today's speaker, Dr. Rachel Bynoe from the University of Southampton. Rachel is a lecturer in archaeology at Southampton. She's a Paleolithic maritime archaeologist with a focus on submerged Pleistocene landscapes. She completed both her MA and her PhD at the University of Southampton, with her doctoral research focused on the submerged Paleolithic of the northern North Sea, through the use of vast historical collections of faunal remains.
Thank you to the NAS for inviting me to talk today. And also I should say thank you to Honor Frost Foundation as the funders. They're also incidentally the people who are funding this year's field season, so double thanks to them. And finally, of course, thank you to everyone for tuning in to listen. I realise you've probably got a lot you could be doing, so I really appreciate you coming to listen to this talk. Today I'm going to be talking about some of the ongoing work at Happisburgh, confusingly spelt Happisburgh, but pronounced Happisburgh. So some of the archaeology onshore and particularly the work that we've been doing looking for the submerged landscapes in this area. I realised that I've probably got quite a mixed bag in terms of an audience, and some of you will be very familiar with the terms I'm using and some less so. So I'm going to start the talk by just running through kind of some of the background to where I'm talking about, when I'm talking about, why I'm talking about it before going off into my work. And I've been assured that Mark will shout at me if I go way past my time, so don't worry, you can have your dinner soon. So to begin, if I can get my technical issues. No, it doesn't want me to do that. There we go. No. Can you see? Mark, is that flashing at you? My screen is flashing. Sorry, I'm having...
No, you're not flashing. It just jumps out of presentation mode from slideshow mode into your...
It's been a year of online and we still can't get it right.
If you could just... Oh.
Okay. That's solid now, yeah?
Yep.
Cool, okay. Right, let's hope we don't have too much of that. So to begin then, where am I talking about? So Happisburgh is located, I'm going to get my pointer out, okay, is located up on the coast of North Norfolk, up here. It's right on the coastline and it's a lovely village. If you haven't visited, you should. But it's also a village that is being rapidly eroded by the sea. So you can see from these images that go from 1996 to 2012, I should say, there's been a huge amount of loss. Okay, so you can see basically kind of this area here from 96 is now gone. And these days, even a big chunk of all of this has gone. And this year we had a huge landslip just inside this bay area. Primarily, of course, this has huge impact on the people that live here, that have their livelihoods here. But it's also impacting on the erosion of a really unique and important archaeological record that I'm going to be kind of talking you through. So when am I talking about then? So when does this relate to? The archaeology and the deposits that I'm going to be talking about today date to the Pleistocene period. This period runs from around 2.6 million years ago all the way through to around 11 or 12,000 years ago and the start of the Holocene, which is the geological period that we're in today. And as you can see, so this probably to some people rather confusing looking graph is essentially showing you kind of the changes in climate through time. So ignore the main details and think about instead about kind of the patterning. So we have age along the bottom, we've got 2 million years here, and we've got us here, so 0, we are up here. So this is showing you how climate, temperature, correspondingly sea levels have changed through that period. We're up at the top, so you can see that all of these peaks are warm periods. So this is when the glaciers are restricted to the northern and southern poles. We have quite nice weather and the sea levels are relatively high. The opposite of that, of course, is the cooler periods in the troughs. Now, these cooler periods are when you see the expansion of those glaciers and you have correspondingly then lower global sea levels. You can see that this has been changing through time, and you can see from about 800,000 or so, they start to get a lot more intense, right? So we're getting longer glacial periods, but also they're much more extreme. And this is really the kind of period of time that when people talk about Pleistocene ice ages, they're really talking about. And the first one that really made an impact in this part of the world, so in Britain, was the Anglian, which is MIS 12, dated to around 500,000 years ago or so. So bear in mind the Anglian, because I'm going to talk about it in the next slide. For this talk, the period of time I'm talking about is pretty much in here, right? So it dates from the Anglian back to approximately 1 million years ago, which, as I'll talk about, is when we first start to see humans in these environments. But briefly then, when I talk about humans, who am I talking about? So we're Homo sapiens and we're not around yet. So during this period of time, we don't actually know the species responsible for the archaeology. It could be someone called Homo antecessor, who we see down in Spain at the same time. Could be a form of Homo erectus. The younger archaeology could be Homo heidelbergensis. The key thing really is not so much who it is, but the fact that they will have different capabilities, different behaviours to those that we know that we have. Okay, and we understand these abilities less. But moving on and back to the time then, so how does this time period relate to Happisburgh? So this is a picture of Happisburgh, and you can see the cliffs in the background. We're looking to the southeast. Incidentally, these concrete blocks used to be the base of some steps that took you to the top of the cliff. So when I first went to Happisburgh, there were steps here and the cliff was about here. So in about 10 years, and probably less time actually, it's moved significantly further back. But these cliff deposits then, what are they? So these are soft sediments, and these were emplaced by that big glaciation, by that Anglian glaciation at around 500,000 years ago or so. Underlying those cliffs then, we know that the deposits there must be earlier than 500,000, so they must predate 500,000 years ago. So the deposits that you can see in the foreground here that we're really interested relate to something called the chromophorus bed formation. And this is a series of deposits that was laid down by kind of big river systems that were draining the landscapes at this time. They're incredible, and they're incredibly unique because they contain, although they preserve really well, lots of organic material. That means that we can get quite a good idea about the environment when these were being laid down and the corresponding landscapes. And the chromophorus bed formation runs from around 500,000 years ago back to approximately 2 million years ago or so. But as I said, I'm mostly focusing on 500,000 back to about 1 million years ago. When the chromophorus bed formation was being laid down, the landscapes looked very different. So at that point, we were permanently connected to the continent of Europe. So you can see the kind of outline in grey. So here's England around here, and we've got Europe over here. We were always connected. So even when things were slightly warmer or slightly colder and sea levels might have changed, the southern North Sea, in blue up here, would have fluctuated somewhat, but we were always connected. And what this means is that the people, the animals, the plants could all freely move, colonize, do all the things that people do in landscapes through this whole area. And we know that they were actually doing that because we have some archaeological sites. So we have the site of Wakefield, which dates about 700,000. But more importantly, for today's purposes, the sites of Happisburgh up here. And here we have two key sites. So the first is Happisburgh Site 1. This dates to about 500,000 years ago, and we find cut-marked bone, animal bone, and we find things like hand axes among the stone tools. We've also got Happisburgh Site 3. Now this is really, really important, this site, because it dates to about, well, just before 1 million years ago, so 0.8, 0.9 million years ago. It's the earliest occupation of Northern Europe, pushed back our understanding of when people were here by hundreds of thousands of years. It's also associated with some of the earliest footprints outside of Africa. And you can see a picture of those down here. And these are finds that came from Happisburgh 3. So no hand axes at Happisburgh 3, just cords and plates. So we often get caught up in, oh, this is really interesting because it's the earliest. We're always looking as archaeologists for the earliest of everything. But the reason these are really important is more to do with the fact that at this early date, what this is telling us about the behaviour of these hominins, of these people. So we know from the evidence that it was incredibly cold. It was harsh. It was interglacial, but it was not warm. Okay, so it was colder than it was today. The winters would have seen significant snow cover. We also know that we, at this point, have no evidence that people were using fire. So how were they surviving in these areas? Were they shooting up quickly from areas like the Iberian Peninsula? Well, actually, that's quite a long way to go, and it's not going to get much benefit in terms of precipitation or temperature. We also know from the footprints that we're not dealing solely with mobile groups of hunter-gatherers, we're dealing with family groups. So we've got children, we've then got presumably pregnant women to think about. If we're dealing with family groups, presumably we've also got people with reduced mobility. So one of the key things about this for me then is, how are these people surviving here? And is there anything that we've lost through the submergence of these landscapes? Is there evidence in those landscapes that can tell us something about how they were surviving? So did these nearer to the coastal zone productive landscapes, the lower kind of lowlands that we've lost, provide something that facilitated that occupation? So these are some of the kind of bigger questions that we're interested in when we're thinking about these submerged landscapes. And this is a brief kind of reconstruction of what it might have looked like. Oh, I should have also said that rivers at the time were slightly different. So I mentioned that the Thames was pushed into its current position by the Anglian glaciation. So at about 1 million years ago, the Thames met up with the Bison River, which doesn't exist anymore, that used to flow out of North Norfolk. So we can kind of see that in this reconstruction. It's a big, slow-moving, low-energy river system. And we know the occupation was kind of on the edge of the estuarine zone. So it's relatively close to the sea, but it's not on the coast. And we know from all the finds that we have lots of different animal species. So things like mammoths, things like rhinos, got hyenas, we've obviously got humans. This is a favourite of mine. This is Savalsus latifrons. It's brilliant elk. But loads of things that these people could have been using to help them to survive in these quite difficult climates. Okay, so that's the end of the kind of basic background to the why, the what, the when, the who. So we know the time period is kind of 500,000 years backwards, and we're dealing with the submerged landscapes of Happisburgh, where we have these really important sites contained within these deposits. So for the rest of the talk then, what I want to talk about is the research that relates to how we're looking at the underwater landscapes, whether they're preserved and how we can pinpoint them. So I'm going to start by talking a little bit about the historic collections in this area. Then the recent collections, so how we're working with collectors these days and the things they're doing. How that is helping us to analyse what they're finding in ways that is helping us to target submerged deposits. And finally, just a little bit about some ongoing work, some thoughts, things to think about moving forward, really. So first off then, historic collections. So we are not the first people to be thinking about these landscapes or looking at stuff coming up on these beaches. So this on the left here is a publication by a guy called Reverend Leighton in 1827. In this, he actually refers to finds that came up of mammoth on this coastline from the 1600s. I also know that we've got people like Samuel Pepys talking about submerged landscapes at about the same time. But what he's talking about in here more locally is really relevant, because he's talking about the fact that offshore you've got trawlers bringing up the bones of these extinct animals. He's talking about stuff he's finding on the beaches, coming up the cliffs, or coming from under the cliffs, presumably. He's also making reference to the fact that he's aware that these must be coming from landscapes that have now been lost. So despite the fact that he's talking about it in kind of creation terms, so he's mentioning things like the deluge of Noah, he's still bringing in these ideas that there are submerged landscapes that these are deriving from. We've also got, of course, the really famous work by Clement Reid, so this is Submerged Forests, in 1913. And he's publishing images, showing potentially where these rivers are going and kind of really looking at some of these deposits. He's also talking about the need to work in a multidisciplinary way, which we know is kind of at the heart of everything we do today. So we've got all of these kind of documents which are talking about these collections. We actually have a lot of the collections, such as Leighton's collections from museums, that we're able to study. But the really interesting thing that kind of started us off looking for some of these submerged deposits was a piece of work from from Clement Reid in 1890. And here he's talking about this big storm in 1877. And during this storm, these big blocks of concreted, he calls it, large slabs of freshwater, clay, iron, stone and pan, thrown up onto the beach. And these contained impressions of the leaves of oak, elm, beech birch, casts of shells, species of fish. Basically, they were finding freshwater deposits which had been concreted and thrown up onto the beaches. So for them, for Reid, this was evidence that underwater these deposits had existed. So they went out, you can see in here, they went out with a boat to try to find these deposits. And they did find an area of seabed where they were throwing the grappling hook over and they were bringing up the grappling hook. It wasn't bringing up deposits, but it was scraping on a rocky seabed. And the arming here, it says the arming showing sand with black specks in this hollow. So despite the fact that they weren't successful, they clearly found an area of seabed where they had this kind of concreted rocky bottom. In the intervening, it's about like 130 years or so, this stuff is continuing to be washed up on beaches. We don't find it forming terrestrially, but it appears to be washing in from these underwater deposits. And occasionally now we also find it encasing bones of extinct species. So this is the pelvis of a rhino that you can see here. So we also have tons of finds that have been picked up along the beaches through that time that we've been able to work on. So some of my colleagues at the Natural History Museum, so Simon Parfitt, Adrian Lister, Marzia Breda, have done a ton of amazing work looking at these bones. And they were able to find cut marks on these bones. So we moved from this kind of understanding that there was a submerged deposit, probably somewhere out there, that was at least fossiliferous, to knowing that there was an archaeological site, because we have proxies here for human occupation. I also left this in because although this doesn't have cut marks, I love it. There's no scale, of course, but it's these are mammoth vertebrae. They're huge. These are southern mammoths, so they are kind of like the height of a double-decker bus. So imagine the size of their vertebrae. But these two are washed up on separate days, but they refit perfectly. So they come from the same skeleton. And what this is telling us, I think it's two things really, which is that the first, it's probably not coming from very far because it would be coming across sediment transport pathway, which I'll talk about in a second. And they're very heavy, so to do that would be quite difficult. So it must be relatively close to shore. But also that things are moving in a relatively predictable way. For these to be eroded out, moved onto the same patch of beach over a relatively short period of time. So that's a kind of a positive, I suppose, if you're trying to find things. But anyway, that's a bit of a tangent. These historic finds are fantastic, but they lack accurate spatial location information, right? So you tend to have labels that say things like Happisburgh or Eccles, but you don't know exactly where and when they came up. They're also probably biased because they're going to be picking up things that are brilliant, you know, so they'll be picking up the vertebrae, they'll be picking up the pelvis, but those little fragments of stuff probably tend to be ignored in favour of the more impressive specimens. This has all changed with working with some of our recent collectors. So in particular, this is Darren, Joe, and we've got Tim over here, and this is Nick Ashton, who's a curator, one of the curators at the British Museum. So up until this point, everything being found and worked on was bones, and we were looking for things like cut marks. These two walked into a fossil roadshow and had with them a hand axe that they'd found on the beach, right? This hand axe looked identical to the one that had been found at Site 1. So that 500,000 year site, they had a hand axe that looked just almost like it was a copy of that hand axe. It's really impressive. But we started talking to them, and it transpires that they've been finding a lot of lithics. So we started working with 3 of these guys from 2014 and still to today, although the analysis you'll see here kind of stopped at around 2017. But they were finding a ton of material, and in contrast to the historic stuff, they were brilliant and would go out constantly and pick up everything they found, right? So the tiny little flakes, the bits of bone, everything was painstakingly collected very kindly because they had to store it in their homes. So it was really, really good of them. They also had GPS, right? So they were getting accurate information about when and where all of these finds were coming up. There's diaries as well that talk about what's going on the beach. But this allowed us to get this really quite significant database together so that we can start looking at the spatio-temporal information that these finds can give us. So although we're working with ex situ finds, so with out of context finds, there's actually quite a lot that these can do in order to kind of to help us think about the patterning and to help us to use that patterning to further understand the onshore record, but also pinpoint areas offshore that we can start looking for the archaeology. So how did we go about doing that? So this is a map of Happisburgh. So the white is sea and this is land. There's Happisburgh up here. This is site 3, so that's that nearly a million year site. Site 1 is here in this kind of embayment here. That's the 500,000 year site. We've also got an interesting area down here, which I'll talk about in a second. A good way to orientate yourself with this, because the maps do jump about a bit, is that it's associated with this kind of, it's called a tombolo. So where the sand is building up against this shore parallel breakwater. These are sea defences. And you can see that the sea defences are variously good, okay, or no, sorry, good, non-existent, good, along the coastline. So I'm going to show you a schematic of this now. So again, we've kind of changed direction. So now the site 3, the early one is up here, the 500,000 year one is here, and we can see the tombolo building up against this shore parallel breakwater down here. So up here we've got some protection from erosion, not loads, as we see the cliffs are still retreating, but not too much movement going on. Around the site 1 area, in area B, because these are our sub-study areas. So if area A up here, area B in the middle here, and area C relating to Eccles North Gap. Area B is really open. There's obviously tons and tons and tons of erosion going on. In between B and C, it's pretty good. So we have groins and there's a seawall. So there's not a huge amount of movement going on. But down in area C, because of this breakwater and the wall, we're getting the build-up of sand. And what you'll see is potentially the kind of catching of artifacts of bones in this area. And the transport direction is shore parallel down this way. So moving from area B down towards area C. So how can this help us understand things? So we started, sorry, my emails are going to ping because I obviously forgot to turn those off before I started. I'm sorry about that. So we started to think about plotting the points out and then thinking about the density of those points. And we were looking at the density of those points as they relate to abrasion. So here, kind of using abrasion as a proxy for movement. So when things are coming up from the sites, we know they're very, very fresh, right? They look like they've just been made. As they move down this way, in line with sediment transport, they start to get more and more abraded. So if we look up in area A, up here, what we were finding, this is the kind of overall density, we've got site 3 here, that's the 1 million year old site. This triangle relates to where we know we've got deposits, but it hasn't been excavated before. And what you find is you get a really beautifully fresh stuff in relatively high densities or very high densities sitting over those known deposits. And then as we're starting to find more abraded stuff, the more abraded stuff is starting to move towards the southeast of those. So it's starting to move in line with where you'd imagine the sands are moving. So what this is indicating to us is that in this area, what we're finding is archaeology that's coming up from known foreshore deposits. It's really interesting because it indicates that site 3 probably has more going on than has been excavated. And also that the borehole here, so HC, which is here, really deserves some attention, and perhaps we could be doing some excavating there. But it's really telling us that most of the stuff we're looking at is coming from those known foreshore deposits, not from anywhere offshore. So what about the other areas? So concentrating on area B here, which incorporates site 1, the 500,000 year site. I'm not going to go through all the densities, but basically we see a similar pattern, which is that we have a high density of fresh material coming up directly over the deposits, right? Not particularly unexpected. There's still archaeology there. It's washing out, it's eroding, it's being picked up. But what we also see is always, with a bit of a gap between them, another patch of higher density material just down to the southeast. So that's approximately here on the map. This does not correspond with any underlying exposures. It's also slightly more abraded than the material we'd see here. And like I said, there's always a bit of a gap between the two patches of high density, no matter how you look at it with the abrasion. So what this started to indicate to us, or the interpretation at least, is that the second group, this group here, is possibly eroding from archaeological deposits in the nearshore zone just out here and washing onto the beaches where they're found. That would account for slightly higher levels of abrasion and also the emplacement over an area where we don't have anything on the beach. This is also, so basically this told us that this is probably a good place to start looking for archaeology. It's not entirely surprising. Okay, so we know we've got the Site 1 channel. So you might say, yeah, you probably go there anyway. But what this is telling us is that there is probably archaeology out there. There's also likely to be preserved deposits in this location. So this was our first kind of key area to go and dive to look at stuff. The area that I love, though, is this area down by Eccles North Gap. So here, so again, you have the tombolo here, and you can see it here, just to orientate yourselves. And we have really high densities of material backing up against this first tombolo. So of the kind of 8,000 or so lithics that we, sorry, 800 or so lithics that we looked at for this, about 70% of those came from down here. So a significant chunk of the lithics were washing up into this area, which incidentally they've stopped coming up over the past few years. This is interesting because we have no known deposits south of Site 1. Nothing has ever been seen in this gap. Nothing's been recorded by historic collectors, and the collectors that we know that walk the beaches constantly have never seen any exposures of anything along here. So there are a few options. One of the most obvious, I suppose, is that things are washing out from here and then moving down the beach and being collected. The problem with that is that the material isn't particularly abraded. Okay, so it's not super fresh, but it's kind of similar to the material that we're finding in this patch here. Okay, so it's slightly abraded. If it had moved all of this distance, we'd expect it to be a lot more battered. The what's the word I'm looking for? The sea defences in this area are also much more secure, so it would take an awful long time to get down there. And again, that would lead to it probably being more abraded. So this led to the conclusion, or again, the interpretation, that possibly this stuff is eroding out of deposits in the nearshore zone in this area and being washed onto the beach as it's getting caught up in the build-up of sediments associated with these breakwaters. And there is some evidence that supports that, or some indication. This is another map that just changes direction, sorry. So again, we have our first tombolo here. So this is basically kind of taking the coastline and making it horizontal. This is area C, Eccles North Gap, and what you're looking at with the blue and the red is like a minus map. So we have two different bathymetric maps. So this is giving us a topography of the seabed, and you're minusing them from one another. So the red areas show you where you have the build-up of sediment. So you can see here you've got these sand waves, which are characteristic of this whole area. And the blue shows you where you've had net loss over that period. And interestingly, we have this whole area of loss, which is pretty much exactly where you'd expect things might be eroding from if they were being caught up in the system and washed onto the beach. So this, despite being quite coarse resolution, so I think there's like 5 years between these two different surveys, so it's not high resolution at all, but this gave us a good idea of somewhere we could go and start looking. So we have these two main areas that we wanted to go and look at offshore to try to test really our ideas. And so that's what we did. We managed to get 2 weeks of fieldwork finding in 2018 and a week in 2019. Last year was obviously a write-off because of COVID. 2019 was terrible viz, so pretty much all of the videos and all of the images you'll see are from 2018, where it was kind of like diving in the Mediterranean. It was absolutely wonderful. We took some side scan sonar data. I think you had a talk on this not long ago. I don't actually show you any because I don't have long, but I'm happy to answer any questions if any come up. You can see our incredibly professional setup here. It worked really well, actually. We've got some good results. So diving wise then, what did we do? So again, a map to orientate you. Here is your first tombolo, Site 1 and Site 3. So we went out, and obviously I was really interested in this area. So we dropped in a bunch of times, we did circular searches, we did drift dives, and we found absolutely nothing but those characteristic sand waves that we see in the data. This got a bit boring, so lunchtime on the first day we thought we'd go up here, we'd drop in quite far offshore Site 1, but kind of in line with it, and drift down this way to cover more ground to get a better look. But it was our first week, and obviously the tides inshore were not doing what they were doing out here, where my app was telling me what was going on. We dropped in and didn't move anywhere, but dropped onto, very surprisingly, some really beautiful laminated deposits. So this was like striking gold on the first day of fieldwork. I really didn't think we'd find anything other than sand for an entire week, so this was incredible, and you can see this organic sticking out of it here. So this is known as OA. This is the wood site, as you'll see, because there's tons of wood. So this is a photogrammetric survey of the site. Right there. Why is this not working? That's weird. Oh, there we go. Right. Okay, so this line is 17 meters long. And so you can see the kind of natural sections here. So the wood you just saw, or the laminated section, was down here. And all of this is kind of eroding out laminations. It does continue underneath the sand that surrounds this area of high ground here. And you can see some kind of, this is that weird worm matting that's forming on top of it. Over here, as you'll come around in a second, is a massive piece of wood. So this scale is 50 centimeters long. This piece of wood is incredible. That's over 500,000 years old, and that is basically a tree trunk. Like I said, the preservation of these deposits is absolutely incredible. And this is just a short video to show you the same kind of thing. So again, you've got these natural sections through these laminations. This is a kind of big chunk of compressed PT material. Again, we find it on the beaches. This is that wood, absolutely huge. And here you can see us on top of the laminations. And this is Crystal, one of my colleagues, who is taking a sample, talk over the noise, taking a sample through the laminate deposits. So nothing fancy, we're using a plumbing tube here to get some preliminary samples so we can split them, have a look at the structure of the deposits, and as you'll see, also take some samples. It's going to flash again. Wait. Let's see. I don't think it likes me doing anything. Okay, so we have this wood site then. What else did we find that week? So at the same time, despite the fact that obviously we have these very, here we go. Sorry, I don't know why it's doing this. Mark.
PowerPoint doesn't like you tonight.
It really doesn't. It's never done this before, I think. I don't know why it's doing it. Yeah. So I just do it from here. Oh, you might be lucky. Okay, right. I'm gonna cross my fingers. So, yes, at the same time, so Tim, one of our collectors, he's also the lifeboat man in the area. He had been speaking to friends. He'd been finding tons of stuff up near Ostend. So loads of hand axes, but also mammoth remains. They'd been out in their boat and they'd also found a drop off. So we thought we'd go and have a look. And we've done a few dives, and eventually, yes, we did also locate some more deposits. So these are a bit different. I'll show you, this is a horrible video, but you get the idea. Really make you feel quite sick. Trying to hold about 5 different things. You can see the broken up deposits on the top here, overlying the cobbles, some really ineffectual hand fanning. And slow motion. I'm going to pause it. Yeah, okay, so you start to see through the sand these other, this is basically different type of laminated deposit coming through. So another area we have preserved Pleistocene deposits coming through on the seabed. This time very much unorganic, so these are not full of wood, these are pretty sterile, come down on some rather sterile sands, but yet another area where we could do further work, I suppose. By the end of the week, we also had a further area, so we'd gone further inshore from the wood site, so towards where you'd imagine those lithics might be coming from, and found another area of deposits, this time termed moonscape, and you'll see why, because it looks like the surface of the moon. So what these are basically eroded blocks of glacial till, and it's crazy. Right, so here's the glacial till. The interesting thing here is that where my damaged hand is underneath is that concreted stuff that's being washed onto the beach. So directly under the till, we're finding in situ concretions, which is basically the stuff that's being broken up and washed on shore, containing all of that wonderful stuff. And this is just a picture of this worm matting again. So similar to the stuff I showed you in the video from the wood site, this likes to form over the hard substrate. So wherever we find this in the area, underneath it, you're either coming down onto that concreted material or to more laminated deposits. So this is a really interesting thing that we need to look at in terms of whether we can use this to pinpoint areas where we know we've got deposits underlying it. And this is the thing that made my sister feel really sick. It's quite brilliant and kind of gross. So moonscape then, we have this in situ concretions. this does make sampling really difficult. So we tried to get some cores. This is the core trying to go through a hole, basically, in the concretion, but everything was really quite mixed up and we didn't get good results. This is the glacial till, which you can also see here. This is also the only area where we've really found any archaeology. So some really fresh flakes coming up, very basic kinds of flakes, but also very similar to the stuff that we find associated with Site 1 and find associated with stuff washing up onto the beaches. So definitely an area where we need to spend a bit of time and go back to. So by the end of those kind of 2-3 weeks, we've had several attempts at taking samples. So we've upgraded our plumbing tubes to drain pipe, which gives us more. So up at Site OB, you can see these lovely laminations and this kind of sandy deposit. And at OA, again, some of those really nice laminations. Right at the end of the last week of Viz, we also found another area about 5 meters away from OA. All the time we see really thick laminations, but over here they peter out, and underneath you have a really high, well, really high, you have a higher energy deposit. So it looks like you've got some kind of landscape change going on here. We didn't have time to section it properly, so this is a natural section that they've kind of cleaned up, and we have a few samples through these which are being processed at the moment. So we have tons of samples. Hang on, I'll come back to this. Yeah, we have samples through these deposits, but what about the archaeology? So I showed you the picture of the flake. Really, we don't have a lot. We're finding flakes and bone in that kind of moonscapey area, which I think is probably one of the highest potentials for finding archaeology. But of course, it's kind of like finding a needle in a haystack. We're covering a huge amount of ground, and often the visibility is pretty bad. Not in these videos, of course, but for the other dives, it's been last year, the last time we were out, it was horrific. However, the last year we were out, this has a lovely story, similar to the 2 mammoth vertebrae that were found. So 2 of my divers, 2 of my colleagues, Rebecca Ferreira and Daniel Pascoe, found each one side of this bone in the same area of seabed over a few separate days. And this is a mammoth, a mammoth ulna, can't get the words out, which is one of the bones. So for us, it's in our arm. It's the one you'd damage if you defended yourself. But obviously this is from a mammoth, not a human. So why this is exciting, what it's telling us, I think, is similar to the mammoth vertebrae, right? So this is clearly broken a while ago. It's quite abraded, but it refits perfectly. And it's covered in bryozoa. So it's been exposed for quite a long time. Presumably it's been moving for a while, and yet the 2 elements, the two broken halves, stay relatively close together. So we know that things are eroding out, and we know that they're moving in a predictable fashion. So this, I think, just gives me kind of hope, I suppose, that if we can, that we should ultimately be able to backtrack to some areas of deposit. And this was further offshore too, so this wasn't coming up on the beaches, meaning that potentially we have phosphorus deposits that are further out, tying again in with those historic accounts of the trawling of remains from further out to sea. So there is more out there. But primarily what we're focusing on at the moment is those deposits, because if we can understand the nature of the environments, we can start to think about how the different areas relate to each other, how they relate to the deposits onshore, and how we can start to think about where we might find the archaeology and how that will relate to those wider landscapes when we do find it. So we've done some pollen analysis, so there's more underway, but in the small, you can see the plumbing tubes down here, small tubes have been looked at. And it's showing some quite interesting results. So at the top here, we've got wood site, so site OA, where we found all those lovely bits of wood. This is not the same as Happisburgh Site 1, even though it's basically in a line with the same channel system. Not super surprising, because it's about 7 or 8 meters lower in terms of its elevation, and it's in a different stratigraphy. We can see that there's a coniferous element here, but there's also deciduous trees going on as well. We think it's a temperate period, but looks palaeologically, so in terms of the pollen, more in line with the earlier site of Happisburgh 3, so the site closer to 1 million years old. On the other hand, site OB, the far site, the one that I said was fairly sterile, despite being closer to site 3, actually looks probably quite a lot younger. and much cooler. So it looks like it's coming out of an interglacial at this site. So we're starting to get an idea of the environments, and from the pollen, possibly where they fit chronologically, although only using pollen is quite problematic. Through the section I showed you where you had the petering out of the laminated sediments on top of those higher energy deposits, we did manage to find a vole tooth. That sounds kind of crazy, but these vole tooth obviously are minute. I think they sieved tons, 80 tons of material at Happisburgh 3 and found one or something, and I sieved 10 litres and managed to find one. So it really was incredibly lucky. This vole tooth, I think, is shooting around the place with various experts in Europe at the moment, because their evolution changes quite quickly, so they can help us to pinpoint chronology. And this vole tooth is from a deposit that underlies those laminated sediments at the wood site at site OA. And we think at the moment this probably dates to around, the vole tooth dates around 1.2 million years, 1 million years ago, so pretty early. And we know that the laminated sediments are therefore a bit younger than that. So it is looking like that's more in line with the site 3 deposits. We've also got some evidence from ostracods and particle size analysis. So again, at that wood site, tons of organic, just tons, to the point that it obscured the analysis. I think there was so much in there, it's hard to pick out what you want. But brackish worms coming through, so it looks like similar to the sites on shore, edge of the estuarine zone. Also, duckweed fern, so this is indicating that there's no long frost, so it's an interglacial period and it's not hugely saline, so again, kind of edge of the estuarine zone. So that's tying in quite nicely with what we know onshore. For the OB site, the far site up in the north, this is beginning to indicate that we're probably dealing here with something that is sublittoral to littoral, so probably a shallow marine area, temperate but cool, so tying in again with the pollen. And the particle size analysis agrees with this. So it doesn't look like those deposits are going to be what's yielding the archaeology, but the fact that they're preserving, and we've got them quite extensively across that landscape, means that we can start to kind of look into those further to see how they relate possibly to other deposits in the area that might be yielding all of that material. So I have told you, what time is it? Oh, I'm getting quite late. I've told you quite a lot about these sites, but I started out by saying my most interesting area was down here, and we haven't really said anything about it other than we didn't find anything. But it's still one of the places that we're really interested in looking. And I mentioned that we know of no deposits south of here, so it makes understanding this area really difficult. And you can see from this, okay, so again, sorry, another map with a weird view. So we've got the northwest up here and Eccles North Gap, the area I'm interested in down here, and all the archaeological sites up here. But we have tons, so these arrows indicate boreholes, tons of boreholes up here. But down this end, we have hardly any. So it's not really surprising that we're not seeing anything. If this stuff was buried deeply under beach sediments, then it's likely that you could walk over it for years and never know it's there. So we want to see where it's coming from offshore. So we did some sub-bottom. So this is basically like taking a kind of section through the seabed to look underneath the sand waves. This is an Inamar seismic parametric system. So it's looking kind of top sediments, kind of top of the seabed, top 5 meters or so. You can see the sea in May of that year was pretty nasty. These are the lines, so this is our tracking. If you've ever seen kind of commercial lines, they're lovely and straight. This is what happens when you're in a rib in choppy water. And I should also say that I had the help of Richard Bates doing this, which was, I probably couldn't have done it without him. In fact, I definitely couldn't have done it without him. But looking through that data is really quite interesting. So we've got channel systems associated with the far site. So there's definitely more going on up there. So these are quite complex. More going on than what we're just seeing in those laminated deposits, which is good given the archaeology on the beach. We've got deposits coming out off Happisburgh site 3, the early site. This channel system also looks like it's in line with what we were thinking would be happening with the site 1 channels, but we've also got this, right? So we've got more going on. This suspiciously close to where we're finding stuff on the beach. So more complexity coming out here, which actually agrees quite nicely again with some of the onshore geophysics that Richard and Martin Bates did several years back now. But most excitingly for me is this. Okay, so I apologise. This is really, I know GIS and some lines is not the best way to show you, but these lines represent where in the seismics you're picking out channels, and I'll show you a few examples in a minute. I probably should have said that at the start. But this is the area where we had that loss. This is the area where we're thinking things are coming from, and this is the area where we have no current information. So the fact that we're seeing, and can you even see my mouse? Let me get a laser pointer out. This, right, this is where I'm looking. So the fact that we're seeing channels coming through in the data in this area is really exciting, because it's an area we've never known anything about before. This is some images of some of the channels that we're seeing coming out, and there are tons of these images. These are just a few of them. This is actually further north, so you can see this lovely kind of onlapping sediments here. But this is brilliant because it's showing us about an area that we thought from the finds must exist, but just had no evidence for whatsoever. And this is beginning to point us in the direction of where we can start looking underwater, even if that means getting vibrocores, so getting cores through these sediments. This is also starting to make me ask some questions about exposure and burial. So on the beach where they're finding the lithics, I mentioned at the start that those have stopped coming up since. So there was a period of time where we found lithics. Before that, there was a period of time where people were collecting fauna, so animal bones that related to kind of an interglacial stage. The fauna that's associated with the lithics is, again, a totally different stage, so a cooler faunal assemblage. So we're seeing, washing up on that beach, different types of fauna, different types of archaeology at different periods. So it's interesting to think about the fact that we have all of these different areas of potential channels, and whether what we're seeing relates to the movement of the sand waves over these deposits. So the intermittent exposure and erosion of different deposits in different areas through this broad area of seabed. And so that's something that I'm really interested in looking into in the future. And it's not something that we, how do I get back to my mouse? I can never remember. No, click over here. Seriously, I should definitely know how to do this by now. No. Mark, do you know how I get back to the pointer?
You click back on laser pointer, because you're already in laser pointer, doesn't it turn it off?
Oh, genius, thank you. Anyway, so this is something that we're also seeing underwater. Okay, so this is an area in the Monks that we haven't had time to talk about today, but this was in 2015. And you can see that the whole area is really scoured out. So you can see these concreted deposits, again, really sticking out in the seabed. They've been there for a while. This is in contrast to exactly the same area a few years later, okay, where we see this. So just massive sand waves and amazing visibility. Look at that, it's so nice. So really interesting that we can see, we know this is happening, you know, we know that sand waves are moving across this area, but thinking about how it relates to the archaeology is something that I'm quite interested in doing, because it's something that we also see onshore. You know, you can come down 1 week and see this, and the same spot a week later looks just like this from different directions. And so thinking about the processes involved in the erosion of this archaeology and its movement onto the beaches, I think is going to be key to kind of unpicking the puzzle of where it's all coming from. So to finish up then, because I realise I'm probably going to get interrupted in a minute and I'll just stop talking. So I'm not the first person, I suppose, to say that out of context finds have a huge value. We see people working on these in lots of different environments, particularly arid environments. They can tell us a lot about the archaeology, and here they're really helping us to target areas offshore. And although we haven't found the archaeology yet, we're beginning to get a much better understanding of the extent and the massive complexity of these offshore deposits, which are hugely extensive. And I think we're only just beginning to scratch the surface, and the more we go and look, the more work there is to do. And of course, there's questions here about extensions further offshore. You know, how we really start talking about those actual actual landscapes in the middle of the North Sea, when we're really just scratching the surface of something that's very close to the shore. Obviously happy to talk about that in the questions. But ultimately also I wanted to highlight the fact that all of this work is driven by the work of the people collecting the materials. So all of our collectors, we wouldn't be able to do any of this without their hours and hours and hours spent on the beach. And I think that's the same for so many archaeological projects. So big thank you to them. So yeah, that's it for me today. Thank you very much for listening. Of course, any questions? Thank you to all the funders that have funded this work through time, my colleagues at both these places. Oh, and this is the collectors on the beach in the snow. That's how dedicated they are. Thank you.
So we have with us Dr. Helen Farr, also from the University of Southampton. We are also joined by Dr. Luke Amkreutz. I just want to say a personal little one about how I'm so loving the idea of dating by voles' teeth. I think that's...
Oh my God, I know, but it's amazing, because when you go back that far, most of our dating techniques, they don't work. So we do rely on kind of Venn diagramming all of these different lines of evidence to find out, where we can date something to. And vole teeth, because they evolve really quickly, are really useful at that period of time. So yeah, it's...
So I just, this is a personal interest really, just in terms of voles, in terms of their evolution of voles, and you may not know anything about the evolution of voles. How much do their teeth change?
So, right, my understanding goes like this. It's limited. It's basically, it's the kind of the roots. So you need I think you need the third molar usually. I might be lying, but it's to do with the way that the roots change from either a rooted to unrooted or the other way around, and various morphological changes of that. I'm definitely not a vole expert, but I have colleagues who are, yeah, I'm here. So find out for you, Mark.
That's all right. It's just a little personal thing. I thought I loved that. All different ways we talk about dating, and I've never really heard of dating through the evolution of voles' teeth.
Clock. It's got a name, vole clock.
The vole clock. Oh man, I've got to Google this later.
Yeah.
In terms of these extreme sand waves, I mean, that sand wave that you showed in that video right at the very end is massive. I mean, there's absolutely monstrous. And then the image you showed from land of one week it's covered with sand, and the next week that it's all completely exposed. Is that after extreme weather events, or is that literally just under benign weather conditions?
So the stuff on the beaches does tend to respond to high energy events. If you have a storm, you can scour the beach out, but it can change just tidally, just with less extreme events. I think the stuff offshore is less certain. I think that so we know that we've got big sand waves that just move along that coastline. Like, you have these big sand waves all over the place in the North Sea. So how they respond to high energy events is unknown, because we don't see the immediate result of it. Whereas on the beach, people will say, oh my God, there was a storm and now the beach is scoured out. Oh my God, there was a storm and now the sand is 2 meters higher. We're not underwater enough to be able, I mean, that would be brilliant, wouldn't it? To be able to measure how that changes and how that affects the movement of the finds. But the sand waves offshore are a permanent feature of kind of movement down the coastline. I
suppose that's a common problem of visibility in terms of in terrestrial and coastal. You can see it, with underwater things happen and you have no idea. Yeah, exactly. We have a question from Richard Vine. Has sandscaping further west at Bacton Gas Terminal affected your work? So someone who clearly knows the area. Yes, this was something that if I'd been allowed to talk for hours, I would have talked about that. So we'll find out in July. Last time we were there, they were just setting up to put the sand onto the beach. We weren't sure what was going on, and the viz was terrible. But I think that's because we just had some bad weather. I would hazard a guess that yes. So certainly, what's happened at Bacton, for those people who don't know about what's happening at Bacton, is a sand replenishment scheme put a load of sands from offshore Great Yarmouth onto the beach, and this contains a lot of middle Paleolithic archaeology. So the stuff I'm talking about, hand axes or the type of hand axes, the Acheulean hand axes, cores and plates, is lower Pal, and the stuff being put on at Bacton is middle Paleolithic. Thankfully, they're
different enough that you can tell the difference, but it does pose a problem when this stuff starts, as it will, moving further south. It's going to start mixing up with the stuff at Happisburgh. But we've also got the problem, which is that they put like tons of sand just upstream of Happisburgh. So I'm like really worried that we're going to get out there in July and it's just going to be like sand everywhere, because we know that that sand is being washed out of that beach. And, you know, everyone locally said this isn't going to work, the sand's going to move. And of course, some of it stayed. I think, you know, I think it's done its job, but the sand, yeah.
So is this done by, this is done by the Environment Agency?
Yes, I assume it's all funded by the, it's aggregates, but in response to, it's a sea defence measure, basically, yeah.
Okay, I wonder if Helen or Luke have a question or a comment to make or a comparison.
I think you're still lucky, Rachel, in the sense that the finds we are having on the beaches actually come from 10 miles out of the coast from a pit 40 meters deep, which is not very much monitored when it was sucked up, and it's rainbowed onto the beach. So actually, I'm quite jealous of the fact that you are able to connect so many of the different archaeology qualities to different positions and to different contexts. So that's something I really think is spectacular, and I hope that we in the future will be able to monitor better where all material is coming from, to be able to distinguish between that, because we also have different time frames. We have Salian artifacts and we have Wiselian artifacts, and actually we're not really aware of what types of settings they come from. We also find different types of abrasion and patinas on them. So there's a lot to gain, and I feel that you're closer to answering those questions than we are. But in the end, I think it's really cool that the outlines of the projects are also in a way similar. That a lot is due to indeed collectors on the beach bringing in information, and that's the same what we're witnessing. We have a really enthusiastic body of people walking on these beaches, and in the Netherlands, there are beaches that they're replenished about 7 million cubic meters every year, and they find spectacular stuff, and we're really, you know, getting a grip on that now, and I really like, you know, the way these projects may even come more together in the future. So yeah.
So that's the thing. So I think that in terms of the soundscaping, we're kind of the same as you, right? Which is that the Happisburgh is different, of course, and yeah, I mean, all those things are amazing. But in terms of the soundscaping, it is those questions of like, where is it coming from, and how do we understand those deposits once it's been taken out and put on the beach? And that's where I think you guys are like definitely, because it's been happening for so long there, and you've got such good, I suppose, networks of people. So every time I talk to anyone about it, really, I suppose, you know, you're doing such amazing stuff, and have been for a long time, it seems, with those soundscaping schemes, and so much cool stuff is coming up, you know, from the Mesolithic all the way through, right? So yeah, I definitely think there's something there for kind of for work, I suppose, for crossover and for sharing ideas of I don't know how you deal with that. It's just it's brilliant, but yeah, you're right. I mean, abrasion, patina, and different typologies and stuff. But yeah, how you get to the bottom of it is tricky.
Yeah. And I think it's going to be the offshore record that is really going to be the linkage there between the Dutch record and what we're seeing at Happisburgh. So I think as soon as you start getting that really deep lower PAL stuff coming out offshore, that's going to be the linkage as well.
That would be amazing.
Yeah.
Yeah, that would be really cool as well. For now, I think that's still the part we're missing. We're not getting beyond those 300,000 or 400,000 years, but of course it should be there. And yeah, it's time to get one step ahead of also the you know, where the sand is dredged from, to be able to maybe have a say in where it's harvested and how deep. I don't know whether that's possible, but that would be really interesting to be able to maybe steer that process.
Yeah, steer them in the direction of some of those earlier deposits. Get them to some cool. Yeah, that would be a gold mine.
I'm finding it difficult to visualize 7 million cubic meters of sand. I mean, how much area does that cover? That sounds massive.
Yeah, well, the Netherlands are pretty low country, right? So we have to. It's for us really important not to drown. So yeah, it's rainbowed onto the beach. It's not in the same place every year, but we noticed that in some areas, for example, the extension of the Rotterdam Harbor, and also a place called the Sand Engine, where there's just a lot of sand, and people are finding fossils and artifacts about every day. We're with some colleagues. Marcel Nikes is in the audience as well. I think we just get finds reported in every day, and there's some spectacular stuff amongst that. One of the things I really like, I have a replica here with me. So actually, this should be black, and this is a piece of flint with where a birch bark tar was attached to it, and it's one of only. Yeah, one of only 3 sites in Europe where this was found. And because we also had a look at the birch bark tar itself, it had really told us a lot about the technical abilities of Neanderthals. But it was found on the beach by an amateur archaeologist walking it. And at first we thought, oh, it's this black pitch, should I wash it off? But we're really glad she didn't. But yeah, it just goes to show that there's so much stuff in there. I sometimes, it's sometimes scary in the way that really you really get the feeling that the best sites for the Paleolithic and the Mesolithic are actually in this area, and we should really try harder to research it, but also preserve it.
Yeah, and that's the worrying thing, isn't it? That I always think that we always talk about these things, like those people, I don't know, maybe I'm just speaking for myself, but when we talk about submerged landscapes, we're like, oh yeah, that's where it all is. It's all out there, all the best stuff's there, but we've got no evidence of that. But actually now, when we do have these beach replenishment schemes, and we're actually seeing what's being taken off the seabed, because it's not being crushed like it would be if it was aggregate, but it's being put on a beach, it's full of archaeology. So it is actually starting to, like, in some way, support some of that, or at least allow us to start really thinking along those lines.
So what always astounds me is the amount of sort of global coastline that's been submerged in that period. I mean, I think it's something like 22 million square kilometers of the world's coastlines have amount of land that has been that was exposed, that's now submerged. So if you think about that in terms of what we know about movement, early hominin movement, and going through into the Holocene as well, that's a huge amount of archaeology that we just don't know because we can't get to it. We haven't been looking, and we're seeing sites coming up more and more and more, and so many of those have been accidental. But now, with the work that's happening, more intense work, and especially in the North Sea, there's so much more evidence that's coming up. So I think it's just there to be found. It's just a case of getting to it, isn't it?
Exactly. Yes, I know, it's so exciting, and then you go out and you see sand. Yeah, there's so much.
But then you fly.
But I guess a really important thing is, we like it because we're archaeologists and we're really fond of old stuff. But I guess a lot of people are just not aware. At least in the Netherlands, they go to the beach and they roll out their towels, but they don't have this idea that they're rolling them out, in front of this huge, very fertile valley, which carries 1 million years of human history. And I think if you tell people that, and then, that really comes to life, and you see how important that is also to create an awareness and to create also the possibilities to research it and to get funding. And I guess just from our side, the fact that we just picked up on it and started working with it, as you do, has really helped in create a certain awareness and a willingness of people to embrace this topic.
That's brilliant. Yeah.
We have a question from Duncan. Are there other similar sites to Happisburgh around, he says around the world, but I'm going to go for around the coast, around the UK, particularly on that sort of east side?
So probably is the answer I would give. There's none being worked on. Happisburgh's quite unique in the sense that it's caught up in the Chromophorus bed, which is really well preserved, and it's outcropping along that coastline. So we see it further south at Pakefield, which is kind of nearest to Great Yarmouth, and then again kind of Happisburgh and to the north. As far as I'm aware, nothing is being washed up at Pakefield. but when we're working with the collector, stuff is being washed up to the south of Happisburgh, so further south than Nichols North Gap. So I would imagine that, yes, they exist. That where you've got these deposits, you'll find stuff associated with them. It's just a matter of it coming up and being found and being exposed and eroded out. Happisburgh's the only one that we're kind of actively working on that we know of. But because the chromophorus bed is this quite kind of unique set of deposits that date to that period, and it's quite extensive, I guess that's why Happisburgh is such a good place to look. That's why we're seeing so much, because normally these deposits don't preserve in the same way. They're much more fragmentary and they're much more dispersed. So perhaps you don't have the opportunities that we do have at Happisburgh, which is why it's kind of a bit of a gold mine or a flint mine.
Question from Kevin: are there any peat deposits in the area associated with the wood?
Yeah. So I showed that big picture of the wood onto water, and there was another picture that looked like wood, and it's like this compressed peat. So we don't find, or I haven't found, seams of peat, but you do find these kind of chunks of peat that's from the same period. And interestingly, so you probably gleaned from my pictures that I'm not a seismic expert. And I did try to get better, but the computer broke and, you know, all these things. But in the seismic pictures, we are seeing in many of the lines really dark reflectors that look like they relate to peats. So I've started mapping those out. I just need to get into something else to do it a bit better. But yes is the answer. There are certainly peat deposits out there, which is, again, really exciting because the amount of information that's contained in all of that, you know. Yeah.
So certainly with high resolution seismics, you can begin to potentially recognise layers that are organic or have organic material in them. So you can begin to start pulling out these peat layers. So that's a really good way of doing it.
Yeah.
And then coring it to double check.
Yeah. And then I'm like, Justin.
Yeah, I was going to say you need support from your colleagues in other departments and other departments with nice access to seismics.
No, I have, but they're fantastic. But you know, it's been a year of everyone's super busy, so it's not really. Yeah, basically need to find some time to go and sit down and collar someone and go and go through it. But yeah, there's tons in there, and there's more to be collected, I think, and it's
In return for brownies, I always find very helpful.
Yeah.
You want colleagues to do anything. Okay, we've got a couple more minutes, folks, and then we are going to have to draw it to a close. I'm sure Rachel's got her glass of wine ready to. Oh, she's actually already got it. Were sites like Happisburgh and Pakefield perhaps within a big river delta of the Bytham and Thames Paleo river systems?
Yeah. So in terms of delta, so offshore earlier, particularly, we know that the North Sea was like a big kind of deltaic system. At the time of Pakefield and at the time of Happisburgh, so when Happisburgh was forming about 1 million years ago, take 1 million as the site, those two river systems were meeting, it seems, and flowing out there, right? But yeah, it's probably a lot more complex than that. So it's easy to kind of talk about this one river system, but what we see is multiple cuts and channels, and as you'd expect, these aren't just one kind of river system. So yes, all of these deposits are associated with kind of aspects of those river systems at the time. So they're the freshwater deposits that were laid down by those river systems at Pakefield and at Happisburgh and at any other sites. So all of that chromophorus bed relates to those river systems, which is why they're probably a focus, because we've got freshwater, animals, plants, open landscapes. Yeah.
Do you get access to data, or does your sort of discipline get access to the knowledge that's gained from the offshore wind farm developments?
The wind farm's been great, actually. Yeah, so Vanguard are putting in so there's Vanguard wind farm, which is Vattenfall, get my words right, who are coming onshore somewhere around Happisburgh, and they've been fantastic. Yeah, they've shared multi-beam data and some of the seismic. So the seismics are interesting because they've used different types. So it's it looks further down because they're obviously interested in engineering purposes. So for that, looking at the shallow water is really difficult, which is why the seismics we collected will show you better resolution in the top sediments. But yes, they are helpful, and they have given us access to data. So yeah,
so is that because they're required to? Do they have to have a contracting sort of archaeologist consultant with them, or is it because you've got managed to build a relationship with individuals?
They so by law, yes, they have archaeologists, but we're not their archaeologists. So they, yeah, I think it's. I mean, I guess there's a bit of that, but there's also kind of an interest in making sure that they're doing what they can to kind of support the archaeology and not to be part of destruction, but to aid in kind of learning and understanding and education. So they contacted us as people that were working in the area, and yeah, so we've kind of built up a bit of a relationship through that. But they were proactive in the first place, which was really nice. So it's good. Yeah.
And Helen or Luke had similar experiences in terms of commercial development and access to data?
Yeah, certainly from my point of view. So I work in the Southern Hemisphere. I'm working just off Northern Australian coast, so quite a long way away. But absolutely, in terms of oil and gas industry, the data is available and accessible. So that's been really useful. It completely changes the scale of the work that we can do. And obviously, if we were collecting that kind of data as archaeologists, it would be really expensive. So it makes it feasible. Yeah.
And Luke?
Yeah, with us, I think the augering data is still a bit difficult from the commercial companies, but one very good example was the extension of the Rotterdam Harbour, where the actually harbour company facilitated an excavation in the harbour area of a campsite, a Mesolithic campsite on a dune, and it was a really big project because it's a really big harbour, and I think of the 5 or 6 times they were in the news with the harbour, it was like 3 or 4 times with the archaeology. So I also think there's a message for these companies that archaeology is something as nature and ecology. It's something very positive they can do. So it's just about finding the means to cooperate, because there's so big economical and commercial interests. Archaeology is usually just a small bit, but it's a very visible and very attractive aspect of their projects as well. So I think there's a lot of perspective for future cooperation in that respect.
Well, great. Well, on that positive note, we kind of run out of time, Rach. Thank you so much to you for your presentation today. Thank you to Luke and to Helen for joining us as well. So on behalf of the Nautical Archaeology Society, our sponsors, the Honor Frost Foundation, thank you for joining us. Enjoy the rest of your evening or your day, wherever you are in the world, and stay safe. Thank you very much.